Hello. All right, let's move all this over. Pause that. Minimize this. Minimize that. Bring that up. Oh, and hopefully this does the right thing. Okay, there we go. All right, nice. All right, so I can start doing what I was doing. So yeah, so I've been working on doing a lot of refactoring to the minimap itself, uh, adding a lot of different. Well, I haven't even gotten to adding the new stuff. It's just been like refactoring it, the underlying bits of it, trying to make it run better because it's pretty tricky in all honesty, making it run faster, it seems. So that's just been what I've been working on. And I figured, uh, you know, people are probably wondering like what exactly I'm doing. Like, people might be like, oh, what are the devs up to? So I figured, oh, this might be a good opportunity because this is actually like a pretty tricky thing. Maybe it's worth actually just streaming it for like a couple hours. I usually will spend more than 2 hours working. It's just, but a stream being like more than 2 hours, it's just gonna get boring for most people. So, 2 hours might be like how long it lasts. Um, but yeah, like I've been spending probably at least a week, uh, trying to, um, improve the performance of the minimap, itself, and it's not easy, because you're ultimately uh, processing a lot of data because the minimap is, each pixel in the minimap is a specific thing you have to process. And so there's over 2,000, if you multiply the width and the height of the actual minimap, like the pixels, it's over 2,000 different operations, which is not a lot for the computer to do, but especially if each operation itself is not inefficient, or I'm sorry, if it is inefficient, then it adds up pretty quickly and it'll make up a small percentage of the entire frame time. Not like, it's not going to impact performance in the most significant way, but it can definitely take up quite a chunk of the frame time, considering it's just one feature of the game. And so, I spent like way too much time. I mean, it's needed, but way too much time just trying to find ways to make it run faster. And I think I'm getting to the end of that, and getting to a point where it's just like, okay, this is the last of what I'm gonna do in terms of refactoring, and then I'll actually move on to adding the new features. Because that's really the reason why I'm doing this in the first place, is because there's a lot of features that we wanted to add to the minimap, and I wanted to make sure that the underlying, the just the part of the code that updates the image of the minimap itself is as optimized as it could possibly be. And I noticed that, many things in the process, realized a lot of different inefficiencies, and we're able to kind of clean those things up. But it's been like, at least a week, like I said. So it's like, you know, it felt like I spent a lot of time doing something very, very, like, just spending a lot of time on a very specific thing. And it just felt, weird. But yeah. So now I'm just trying to say, like, okay, the last thing that I'm trying to do to try to make it so that it's not as impactful on each frame is making it so that, uh, the mini map will render, it'll like re-update itself, not every frame, but like every other frame. And so, uh, we can see, let's see here. Uh, yeah, so it will, this is like the code that updates it, but it doesn't necessarily need to update every frame. So what we can do is we can say, we can have it update in kind of pieces over multiple frames. And so that'll mean that each frame is spending less time updating the map, and then it can just do it in pieces in each frame. And so if the game's running at 60 frames per second, let's say, then maybe the update rate of the minimap will be 30, which it doesn't need to be that high. You want the frame rate of the game itself to be as high as possible for, refresh, for response time, for like input response time, and, you know, just having the game be smooth, easy, makes combat easier when the game is smoother and you have the monitor that supports it. But the minimap itself doesn't necessarily need to be at the same update rate as the game itself. It doesn't need to be like if it's running at 120, it doesn't need to. So this code will make it so that like it'll the rate of updating will be half or maybe even a third or a fourth or something like that. So it's just not going to be as impactful. Um, at one point we actually tried and it succeeded, but we did like multi-threading, where the entire map would be updated in pieces on individual like threads or tasks in this case, asynchronously. But and we might still do that right now. Right now, it isn't doing that because trying to make it do that again effectively is not simple. And so what we might end up doing is just saying, let's not make it be multi-threaded, but just have it be, you know, just cut up the work into multiple frames. And then if we still need to do multi-threading, into some degree for whatever reason, we could still do that. But at least it means that the CPU doesn't have to dedicate more resources to the minimap as well, because that's another important perspective, is that when you're multi-threading, you're telling the system, you're telling your hardware that you want to use more resources for this particular thing. It makes it run faster, but at the expense of the hardware, which, I mean, for something like this, it makes sense. But anyway, let me just move on. This is what I was last working on, because the whole system needs to know at what point it's in the like processing of the minimap. It needs to know what state it's in. So that's what I was doing last. And this is kind of where I was like, oh, maybe I'll stream this doing this. So this is what I'm doing now. All right. So patches, instancing buffer size. Also, just so anyone listening knows, I don't currently have the chat open. I don't see it, but I will look at it, open it up once in a while, and actually see who has messaged, but I generally don't. I just assume that there's people listening. If no one's listening, that's fine. Usually, I just assume that I'm not streaming until I go, oh, let me check the chat, because there's probably people saying things. I find that's the most efficient way to stream and code at the same time. Other than now, I feel like I have to like narrate myself a little bit. Anyway, I mean, that can help. So, all right. So the current batch, so the current state, so rendering. Okay, so we need to check. We need to do like this check where we say if the map rendering state is equal to rendering, because we only want this to happen when it's rendering. And that's going to be all of this, or yeah, it's going to be all of that. This code could be written better, but it's going to require like a new function or something, which, I mean, I could probably do, but maybe I'll do that, but not now. Map generation state. Okay, so when it's rendering, it'll say, so what it's going to do is say, so this is the batch, like each batch is like 1020 things. So we're not going to need this. We're just going to do this, but we need to know, do we still need to know the batch number, or is that not really necessary? I think it is necessary for knowing, like, yeah, I think what we can do is, oh, you know what? This could actually make the code a little bit better. If I say const, or I'll say if remainder batch, because not every batch is the full size. If remainder batch is greater than 0, that means we have a batch that's remaining. Then Hmm. Can I make this, well, this is a, I wonder if I could do that. I bet you I could. It's unnecessary, but we'll see. If, yeah, it's going to throw an error. A const field requires a value to be provided. So if I say, it doesn't allow that, that's sad. That would work. I think what I would have to do is, oh, you know what? Not that this is what I want to do, but I'm pretty sure. Is that a thing you can do? I don't know. Let's see. I'm getting. Huh. Can I do this? No. That feels weird. It feels like I should be able to do that. I guess maybe this is just not a thing you're allowed to do, which is kind of sad. Because in reality, I should be able to do that. Or maybe I would want it to be read-only. Maybe that's... Read-only... What? No. Write-only. Yeah, I guess I just can't do that. Um... Oh, did I leave out? Yeah, too many clipboard things. Uh, I mean, in theory, it should be able to optimize that, but if remainder batch is greater than 0, then total batch is plus plus. Yeah. It kind of sucks that I can't make it const. Or, yeah, I can't do that, or even read-only. Well, it doesn't make any, yeah. It's just one of those things that you can't do here. Because, yeah. So, and, so if that, so that's the total batches. So that kind of gives you an idea of that. And this might not even be used. But I feel like I'm going to need this. So we need to know the... Oh, you know what? That it is going to be needed because you need to say current batch, and you're going to say I don't need this anymore. And what was I going to do? So you go through this loop. This whole thing processes a single batch. So the difference between them is that when you... Oh, okay. So these things are also... Okay, that's going to be something that I also have to consider. Unless, of course, I want to... let's see. Part of me... Am I going to benchmark this? Am I really going to... think I might as well look at the chat now. Let's see. Holy crap. Okay, so hey Vapor Zone. Mini chat monitor. Well, here's the thing. I have a chat monitor, Scott. It's just that I don't have it visible because I'm going to be distracted by it. And I know that your setup is different in that regards, and it's literally a basis of how our brains work. It's a matter of like, you know, I feel like you could probably get more done being distracted, but the thing is I feel like I would be the type of person that would get less done, right? And I understand I say this, which is kind of ironic because I send tons of messages on your stream of like just sending messages and distracting you. So it's kind of in a sense, in some sense, hypocritical. Uh, but at the same time, it's up to you whether or not you want to be distracted by those messages. It seems like you get a lot of progress done even with constantly reading messages, but like this is why I have to do it this way. I have to uh like have the chat be hidden because otherwise I'm just gonna go on and on and on and on and on and on and on. Which from knowing you, Scott, yeah, I don't think you do that as much. You don't ramble like I do about stuff sometimes. Yeah, like what Below the Stone official just said. Like it's street. Hey, Necro Gaming. Yeah, it's I mean, I don't know exactly. I know you've shown it. I don't know exactly how big it is. Uh so what was I going to say? It could be like, I don't know how much of the chat you're actually seeing, but at the end of the day, like I feel like if I had what you had, Scott, if I was just like coding, I would like in the corner of my eye, I would see it change, and it would be this kind of like this really terrible urge to just read it. Um, and the difference between you and me is really it's just that when I read a message, the amount of words that'll come out of my mouth after reading it is probably at least 5 times as more as what would be in your case. And that's just the difference between you and I. Like we're different in that way. Yeah. Oh, okay. Yeah, yeah, yeah. That's a good point. So, uh, yep. All right. So I want to, well, I guess I'm going to benchmark something now because I'm just like, this is one of the things when like Scott Host was helping me and I was like doing this thing and I might not be able to do this anymore depending on how I want to rewrite this code. And I remember like benchmarking, like trying to see if how much of a difference this made over doing like a division and remainder. And it seemed like there wasn't not much of a difference in that. And so I'm going to do another benchmark just to verify that it doesn't matter. It seems weird that it wouldn't matter because a division usually takes more CPU cycles than this would, but maybe there's something about this. I don't know. Maybe there's something that I'm not aware of going on here, but yeah, we're gonna see if it actually has a change in performance if I go back to using divrem in this case uh, to get the X and the Y positions for things. Because I would probably need to use it if I'm going to be writing this code in a slightly different way. I just got to make sure map generation rendering, and it's gonna do this, and then it's gonna do this. Yeah, I think this isn't gonna matter. And then we're gonna say we're gonna do all this stuff, but then of course what we're gonna do is we're just gonna for now we will go to the bottom here and just say ready to render so that it actually gets down to this point and does this and does this. And map generation state, so that should work. the way it did before, except yeah. So we'll see how these things fare with all of that going. And you'll actually, anyone listening, viewing right now, will actually get to see how slow or fast, depending on how you want to look at it. It's kind of in this kind of middle ground, this awkward middle ground, how much time the minimap actually spends, takes away from the frame, the ideal frame time. Just let this do its thing, of course, and actually run the game. Also, so of course I talk about benchmarking, so I have my profiler slash profile analyzer window, so I can kind of test this stuff, and I'm leaving it on my separate window, my second screen, because there's just no space. Oh God. There it is. Yeah, I hope there's a lot of people uh, watching it. No, not that many actually. There's 10 views, but currently 2 people viewing, it looks like. But you know, there's not many people that I think are going to be interested in this. I'm doing this largely because you know, people might be wondering what the devs are up to, and I just figured this is a nice way to. It's a 2 birds 1 stone. I can get work done and also show people what the heck's going on, at least on my end. So that's kind of the motivation behind deciding to randomly do this today. I wasn't planning on doing this. I just decided, hey, this might be a good time to do it. All right, yeah. So there's the minimap. It's funny because for a while, getting the minimap looking like this, as it used to, as it originally did previously, as it currently does for anyone playing the demo, getting it to look exactly like this took a little time, mostly because I was doing mostly optimizations. But once I got down to like once those optimizations stuff was taken care of for the most part, then I was like, okay, because it was like it was showing the wrong color in the map for some reason, and I was like, why is it doing this? And I believe it had something to do with the shader itself, because I had to make a specific, like, very, very simple shader. Why am I doing this? Why am I mining? So, yeah, I wanted to just test the actual speed of the minimap. All right, so, and right now the minimap is happening here in the rendering portion, and usually it doesn't take up that, oh, I know why it's because the, so this is interesting. So the minimap does take up 1 millisecond, which is not a lot of time, but you know, when you want your game to run at like say at let's say 120 FPS, gives you nice. That's really good for in a general case for a game to run at 120 FPS for response input response time and also smoothness for people who have you know the monitors that support it. Um, you know, for 120 frames per second, all your code needs to run in. It needs to run in, I believe, 8 milliseconds. I should remember that now. So 1 millisecond, the minimap taking 1 millisecond is a considerable portion of 8 milliseconds of your time real estate, if you will, your time budget of doing that. But this is taking 1 millisecond largely because each time I launch Unity, it goes back into debug mode, which is I think the sensible thing to do, but it means that I have to now click on release mode, recompile the code, and then relaunch the game. And it will run faster. The minimap will run faster through the virtue of that. The code is just optimized, or it's more optimized. It'll just run faster because of that. And you'll actually see the true time. Of course, this might be the actual, like when you run the game, like it might even take less time. Like who knows? It might run even faster as a standalone build, and you can actually benchmark a standalone build. I just haven't done it yet recently with testing the minimap in particular, so I have no idea. Might be worth doing just to kind of get an idea of what the end result is going to be for like users, like how long the minimap takes. Because this is one of those things that I've, even though it's just one piece of the game, it's something that I've spent a lot of time, like I said, like a week trying to make it better, and it's not easy. So yeah, and it's just, it's like, yeah, I think that's all I wanted to say. So now with optimizations on, the game runs faster in general, but also you can see the minimap. Well, you can kind of see here the time. It's under a millisecond, which is good, but it'll vary, right? Like sometimes it takes 0.4, so it's like half, right? In debug mode, it's running twice as slow. It takes twice as long to word it that way. And so you might say, well, what's the average, right? And this is a cool thing that I discovered recently while trying to see if there was such things that exist, and I discovered this, and I was like, oh, I love this already. And so it's this thing, this window, called the Profile Analyzer, and it's a separate package that you have to download in Unity. But it basically just gives you a way to kind of get some general stats about what you see in the profiler. So it's really nice. It's literally just called the Profile Analyzer. So I got that, and really nice, because ultimately, all these different frames, it's taking different amounts of time. You want to know what the average is, or what the minimum, or the general. You want to get a gist of what the performance is of this thing, right? You can kind of get an idea here, but without this, normally what I would do is I'd try to take a picture, a screenshot of this, save it in Paint, make my code change, rerun the game, look at this graph, and sometimes the scaling changes and things like that. So then it's not a very elegant way to make these types of comparisons. Where here, this whole thing makes it way easier. And that's interesting. Oh, okay. Oh yeah. So here, what I can do, and the last frame for whatever reason is like not like doesn't give a correct value. The most recent frame. So I'm just gonna like select in here. I'm gonna select like kind of excluding the margins, and I usually do that as a rule when selecting the time data that I want to consider. Just kind of excluding a little bit of margin for any weird frame data. And it looks like the mean, the average, is 0.39, which is, I thought I had that written down somewhere. Now, this is like, and I guess I should write it down. In fact, I'll write it down in Notepad, because, yeah, 0. And this is literally what I've been, like, most of my time I've been spending just, like, looking at this and, like, writing numbers down, making a small code change, waiting for the thing to recompile, and then hitting this play button, and then the level has to regenerate, which is its own little, takes its time. This is the reality of procedural generation. You have to, each time you run the game, you have to wait, unless of course we made it so that there's like a pre-made level, so I don't have to worry about generation. It just loads it in, which is something I thought about like at least 50 times over the many years of working on the game, thinking, oh, what if there was just a pre-made level, so you don't have to wait as long for things like that. Like caching a level and then reusing it multiple times, so you don't have to, kind of wait for it to generate and stuff like that, if the generation you don't really care about. But yeah, 0.3972, we'll say. 0.3972. Oops. And of course, you can kind of see there's like these little spikes. So for whatever reason, it just decided to take way longer on that particular frame. So those are kind of like what people will say, like in the math world, they'll say like outliers. But really a true outlier would be like if it was spiking up here. That's a true outlier. That it doesn't represent the common scenario. The common scenario is that the frame rate is going to be like if I select, say, this little region right here between these two little spikes, which I think is right there, you can see the mean is actually 0.395. So it's ever so slightly lower, right? Because I'm pretty sure I'm like getting between these two areas here. And you can see that if I like sample one of them, it's like 0.45 there actually. So 389. So it's like saying, okay, yeah, most of the time stamps are like in this kind of zone, essentially, is what we're getting at. Like you can see that clearly just looking at it. So what I'm going to do is I'm going to clear this to try to make my results a little bit more more significant, I suppose. I'm going to move to a new location, let it run some more. No spikes this time. Well, yeah, that's good. So there. And then we'll grab the data again, grab the new data. And I'm only going to do this twice, because doing it twice kind of gives you an idea of like, okay, it better gives you an idea of range, like the range of averages. So if I select this area, we got a mean of 385, 385. Is it really just 3858? Yeah, 3858. 0.3858. So it kind of gives you, oh, did I put extra 2 there? Yeah. An idea of like this is the range. And I can continue doing this to increase my certainty of, what the actual time is. But this kind of gives you, I mean, I'm a glutton for this kind of stuff. I might as well do it again. Of course, every time I move my mouse around, other things are going to slow down. So I'll do it one more time. Third time's a lucky charm for statistics. And we'll just select right there. And in this case, it's 3832. We'll round up. So it just gives us, again, we got 2 results where it's 38 instead of 39. So this gives us a good idea of like where we are with that. And so then what I'm going to do is if doing a divrem, and people are like, what do you mean divrem? What is this? So instead of doing this to determine the x and the y that we're going to plug in here, instead of doing that, what we're going to do is I'm going to comment this out. And instead, I'm going to say math dot divrem. Yeah. I keep forgetting. What do I put in here? It's yeah, I believe it's just yeah, the minimap width and the I. So it's I and minimap width, like that. And then out. They call it out result, but I'm pretty sure. Yeah, I'm pretty sure this is the remainder. So the remainder is always the x. Yeah. Yeah, the x. And then so say out int x. And then int y, like this. So, and then I can comment these out like that, right? Also, this would actually be not the O. Okay. So in this case, I would need to do something slightly different because I obviously don't have I. I need to know where I am, what exact point in the grid I'm focusing on. So this is going to require me to understand my starting position. So maybe I could, well, yeah, we'll see. Yeah, I'm doing a bajillion different things in my mind right now. So the I is going to be I think what I'll do, yeah, this is just, I'm just doing this for testing. So what I'll do is, uh, um, I'll do that. So a bit of a I plus plus. So we're still doing that, still doing the plus plus, and that'll kind of alleviate that predicament. But then we still have to obviously figure out how that's going to be, how this I value, if we're going to use divrem, how we're going to do that, unless of course we have some other, we'd have to say like, oh, this is your number or something like that, or preserve that kind of positional state in a sense. Which we could do it either way. I'm just curious to see if this is actually slower or faster or whatever. It's not going to be faster. Or maybe it would. I don't know. We'll see. Uh, so, oh yeah, I got to comment this out. And yeah, but then this has to be I plus plus. Yeah, there we go. Divrem, and so for those who don't know, just saying this for those who are wondering, so divrem is, it's basically just, like integer division. Normally, if you would just say like, a divided by b, something like this, but it's doing both a division and a remainder at the same time. So the idea is you're being more explicit in telling the compiler that, hey, usually when you do a division in the CPU, you also give me a remainder. You also produce that while executing the division instruction. So I want that result as well. And so you're just trying to be more explicit to the compiler, that more clear to the compiler that you want to get that information so that you're not just performing another division, which would indeed be a lot more work, unnecessary work that the compiler would be, or the computer would be doing in that case. And the divrem you can use to kind of convert in this case, wait a minute. Yeah, you would use divrem to convert a one-dimensional index to a two-dimensional coordinate xy coordinate pair that would be used to, well, normally you would use it in like, let's say indexing like a two-dimensional array, but usually you do that the other way around. You'd take a 2D coordinate and convert it into a one-dimensional index for that array, which represents a grid of data. But this way it's like the other way around, because we're iterating kind of linearly and populating a buffer, a one-dimensional buffer, but with data that is in itself two-dimensional. So yeah, we're trying to see if this is faster than this. It looks like this should be faster, but based on what I've seen before, it's slower. So we'll see. And I think I should probably save so that it's compiling while I'm talking at the same time. But I believe that's it. Uh, yeah. Yeah. And hopefully that will give us an idea of what we need to do, what we can do. Minimap width, yeah, I gotta make sure that's correct. Yeah, I'm just double, triple checking all my work. Let's read the chat. YouTube live view count is not accurate. Yeah, I know. It's weird. Hey, Scott Bloom and host. Okay, so it's clear. Well, first of all, let's get out of this. There's a froggy. Froggy. I know, Scott. I know. I know. I just thought to myself, for those who've seen the YouTube video, I was thinking like this might be actually pretty. I mean, we could probably do this because this is a Wikipedia page, I believe. We should be allowed to do this. Where for the frog, is it gonna show up? What's going on? Oh, I didn't kill it. I have to. Unfortunately, I have to kill a frog for it to show up. Um, but let's see. I just thought to myself, what if we? It's probably not gonna. Let's see. Uh, let's see if it shows up. It's like I don't know if this was the page, but there was a video. Is it? It wasn't. Maybe it wasn't this, but it was like well, it was this video making like taking this text and making that the. I mean, I know it's called a toad. I get it. I mean, there is a Wikipedia page for the toad, but like you get what I'm saying, right? I wonder if they're. Oh, here, wait, is this? Froggy. I want to find this page. Did they change it? I don't know. Yeah, well, this is what's coming up, so this must be it. Even though it looks like it's changed. But yeah, you get it's like thinking, like just make the Scottish Wikipedia entry uh for frog be like what you see here. Okay. Okay. Anyway, uh yeah, this is what I was meaning to do. Um Clear, and we'll see if the div rem really is slower than doing it the other way, then there should be a significant difference in what we'd be seeing right here, right? This is Scott Host who suggested this originally. Who said, or actually no, he didn't suggest it. I thought, oh, could I do this? And then he said, yeah, that should be faster. And we were kind of in agreement on that. And then at some point, I like did an excessive level of benchmarking and decided to benchmark that particular thing, and it seemed like it didn't make that much of a difference on average. Uh, and you can kind of see here without even really getting an average that, you know, uh, it's not making a difference. I mean, we could see here just to make sure, just to verify, like where's the benchmark? So that's where the benchmark starts. It does all of this. So the only thing that's really different is that we have an I counter. We're still counting up, right? Like we are here. We're still just counting up incrementally with our loops. And then a lot of loops within loops here, but that'll kind of be cut down when we change how this code is written. And yeah, it ends here. So in reality, I think a better way to test this particular thing is not to be testing the whole thing, because there could be a lot of random factors that makes it hard to tell like which way's better. You'd have to make a more isolated test, but I'm not going to do that. It's like if we're thinking, oh, it's going to double, like doing it the one way or the other is going to double the time it takes. This is going to be like a very minuscule difference, right? So if we select, like if I do this, if I select here and so we'll write these down. So 0.4464. Oops. And we'll do another one. Also, the min is 0.37. So, I mean, it honestly might be a little bit faster. Like, it looks like it actually might. But to a very negligible degree, keep in mind. That's another thing to consider. Is it really worth, like, is it really something worth, paying for, I guess? Is it a worthy cost, right? Because the one way has strictly a programmatical limitation, right? The one is sequential. The one is more sequential in its nature, and the other one is a little bit more procedural, right? It doesn't matter where the one requires that you go through everything in order, in a specific order, whereas the other way, it doesn't matter what index you start at, you can convert it. You're just doing like a direct conversion. So you can generate stuff in any order, which I do like. Yeah, I'm just trying to get to another location. So do that, clear. And then pull the data, and we'll see what we got. Zero 0.4094. This seems to be a bit definitive, I'd admit. Significant difference. It's also let's just do this. Try to get to a different zone. Uh-oh. There we go. That's actually what I wanted. Hey, man. Oh, God. Oops. All right. Yep. Clear. Do one more. And pull the data. Zero 0.40, so it's 4029, we'll say. So it does look like there is a bit of a significant difference just doing these kind of few tests, that the one over the other does take a tiny bit more time, like tiny, and which is worth considering. But also, this is milliseconds. So if we look at, say, well, let's, for the sake of viewing it, I'll open up my computer calculator rather than using my in-person calculator. And I wonder if there's... I'll do like... I'll just do like an in-between. So are these... interestingly, they're in order. The third ones are always are the fastest. So we'll say 0.3972 plus 0.3832, and then divide by 2. So it's about 3902. Right. Oops. So the average of the averages is 3902, and for these, it's well, it's not the average of the averages. Actually, the average of the averages would be, I might as well do it, 3972 plus 0.3858 plus 0.3832, and then divide that by 3. That gives you that number, 38. Well, okay, so that's the average of the averages, but then this is the middle point of the averages. And the reason why I did the middle point is just because of the fact that, obviously we're getting like multiple averages and we're trying to say like what, trying to get an idea of like where the middle ground here is of this. And yeah, well, we'll just go with the average. It's just like I have to set up a rule and then stay with that rule. So 3887 is what we'll go with, 3887 for our final average for that test. 4464 plus 0.4094 plus 0.4029 gives us this, and we divide by 3 and we get this number, 4196. So in total, that's the average of with using the division. And so clearly it's bigger, but how much bigger, right? And you can just subtract 4196 minus 0.3887. And so the difference in this case between the one and the other is a whopping 0.0309 milliseconds, which if we step that down to the next unit is that would be, we'd move over 3 spaces, so that would be 1, 1, 2, 3. So that would be 30.9 microseconds. So, which actually is, I would say, that is significant, right? But in terms of like a larger scale, 30 microseconds improvement on average is not it's not a major improvement. It's not the same as like saving, if the difference was a whopping 0.1 milliseconds. If I was able to save a definitive 0.1 milliseconds, also you can consider, what's the range of averages here, and you can say 3972 minus 0.3832 is about 0.014. So that's, it can go from that one range to the other, and then 0.4464 minus 0.4029 gives you about 0.0435. So I know that's not the error, but I'm calling it the error. So this has so far a seemingly smaller variation. This has a larger variation, which leads me to think that there might be some scenarios where even with the division, it might be as fast, or it might be, there's like a little bit of overlap. Like sometimes, the division, this one might be as fast as this one, but then sometimes this one might be as slow as this one. There's a bit of overlap between the two potentially. But obviously, as you can see here, that might not be the case. It would obviously be better to also look at the minimum time, right? And to look at, the minimum of each of these tests. I'm getting way too deep in the maths here, but this is literally what kind of peer into what the heck I was doing the past week. This is literally what I've been doing more or less. So, it is a noticeable difference from just that one little code change, but it's not the same as like saving 0.1 millisecond, right? A that much of a difference, which is in terms of microseconds would be 100 microseconds, I believe, actually, because you would move the point, it would go 0.1, and then you move the point 1, and then it would be 1, and then 2, 3. So 100 microsecond difference would be a lot better. It would be a much better, respectable kind of difference. So for what I'm doing, this difference is like, it's very tiny. I may have just gotten out of school, but I'd be damned if I miss a dev stream. Okay. I thought where you're going with that is you just got finished with school, and then now all of a sudden I'm doing a bunch of math, and you're like, oh, not this again. This feels like school flashbacks. Anyway, so all of that just to say, okay, doing the division thing is a bit faster, it appears, at least from that specific test. But what was I saying? It's a very small difference, mind you. All right. So let's get to the main point of why I'm here. So I wanted to change I wanted to comment this out. Oops. Comment this out, because what I'm going to do is I'm going to say, well, the batch. Yeah, the batch. Oops. Current batch is going to be some important information here. So we're going to say, so we still do need, the only problem here is we still need to like know how we're starting this whole thing, like how it's starting up. And so this is so weird, but I know why I'm doing it this way. So I feel like I have to like, sometimes I have to like write out the math. It's like the current batch could be 0, it could be 1, or it could be 2. And in any of those situations, the starting index I, in this case, is going to be 0, or it could be 1 times the instancing buffer size, right? Or 2 times the instancing buffer size. Which I don't think that's correct. That would be, yeah, no. Well, yeah, no. Well, not in this case. Well, the thing is that eventually it's going to be, this is like the starting position. So this is like, this one's going to go for, this amount of times. This is going to go for this amount of times. But this one is not going to be that. It's going to be smaller. So it's going to start where, you know what? Part of me is just thinking I should just do, yeah, I should just, you know what, like, avoid this extra math and just have some extra state. Doesn't matter. What am I looking at? Oh. Current grid index. Let's do that. And then we'll put this current batch 0, current index 0. Current grid index. And that'll kind of, I don't have to worry about that math anymore. And because ultimately these times that we're seeing here, the idea is that ultimately this is like the time to generate the minimap. So what we want to do is we want to break up the work, like I said earlier, break it up into smaller pieces so that piece of it happens on one frame, part of it happens on the next frame. And so the idea is that in total, uh, this, take like say this number and divide it by 3 or something, or divide it by 2, right? So it's going to take less time, which will help with the frame rate, but make it so that the minimap updates at a lower rate, which is fine, right? We don't need it to update that often. It's not going to really affect people that much if it updates on a lower frequency. And if the game runs at a higher rate, well then by that virtue, it's automatically going to do that, sort of. It's kind of like we're rebalancing things, rebalancing the time in that kind of sense. Let's see here. So yeah, I'm not going to use the I anymore, but instead I'm just going to say, I'm going to do current grid index. I wonder if I can do like int current grid index, or I'll say int I is equal to the current grid index. And the reason why I would be doing this is because constantly incrementing this might be slow, potentially, I think, based on tests I've done. And it might be faster to just copy. I mean, it might not make a difference, but I speculate that it might be faster if I copy the value like this and then just increment it. And then when I'm done, at the very bottom here, I would basically just say, I would reset the value based on I. So anyway, so we're rendering I is equal to current grid index. We go through, we do this, and this as well. Bring that down. And that's all we want to do on this particular frame. We just want to do that. We don't want to do, and this. We don't want to do this, though. With that, yeah, we're going to say current batch plus plus. So once we do this, we're going to say current batch plus plus, and then we're going to not do this. We only want to do this I may have to mute myself in a second. All right. Let's see. So this cannot happen. Let me cut this out for the time being. It'll make it harder, or make it easier to kind of think through this. So if map generation state is, so for rendering, we do this, but we only want to do, yeah, so at the very end here, we would say, current grid index is equal to I in this case, to basically kind of provide the data back to it. I think what I'm going to do to try to wiggle this code back in, this piece right here, this can be kind of reintegrated in here in this whole loop, because basically what we're saying is int, we'll call it batch size, and we'll say if, let's see. I love having to reload my device anytime my phone loses connection. Oh geez. Yeah, batch size. So how do we know what the batch size is going to be? The batch size is going to be, well, it's going to be this number, but it depends on whether or not our current batch is yeah, this is tricky. This is a real puzzle to think through, because if current batch is greater than yeah, you can't really tell whether or not there's a remainder batch depending on that. You have to like figure that out from a different source. You have to say like, you know, you'd have to say like const, and I think you can do that. You can say const bool has remainder, which would be equal to remainder batch is greater than 0, which you can do because you can. And then that actually should, because it's const, that'll mean that it's not like, it can be compiled time figured out. And then we're gonna say the int remainder batch index is equal to, in this case, well, that's this, and this is only used in that situation, obviously, but you'd say it would be the full batches plus 1 in that case. And so what we would do is we would say if current batch, so if we, yeah, batch, so normally batch size is just this. But if as remainder, if we have a remainder and we current batch is equal to remainder batch index, then the batch size is equal to should rename it to that anyway. Remainder batch size, because it's a size. Like that. So that, in theory, should do it. Probably can't make this const. Obviously, I can't. It's just one of those annoying things. So batch size, and then in theory, so has remainder, and the current batch is equal to the remainder batch index, which is our full batches plus 1, which in reality is the same thing as our total batches, ironically, which I might not end up using. Or maybe I will. We'll see. I mean, the remainder is always the last thing anyway, so we can kind of use that virtue to know when we're done. But we're going to say, I mean, yeah, we could do that, honestly. So we could say 34 views. Interesting. 34 people have viewed the stream. That's nice to know that at least that many people viewed it. You know, let's see. Hey, Dave. Is there anywhere else where I need to use it? Batch size. All that batch size. If we run through the code and we get to the end, and we're also going to have a bool, I guess. Can we do this? Or final batch. We'll just do this, why not? Final batch. And we'll just set this to true, just to kind of latch onto that data. And then when we get to the bottom and we do the mesh thingy-majig, and we set that value and we say current batch plus plus, and then we're going to say if final batch, then we put this in here, I believe. Yep. I always was like actually not really sure if Dave Fish was anyone, an individual from the Discord named anyone. And so, but I was pretty certain that that's who Dave Fish was. Let's see. And I think that's... I might be missing something here. I'm probably missing something. Yep. Yeah. I figured Dave was anyone. I wasn't sure, but yeah. So now we got our tiny little nice state machine. All this other stuff. So if map generation state is idle, then we just immediately start rendering. We go into the rendering state, set things up. We do this, is this even necessary? Some of this code might not even be necessary to do unless we're in the rendering state, because we're doing like a lot of stuff. And you have to consider, like, you know, we could be, well, if we're in the idle state, by this code, by this point, we're probably never going to be in the idle state, right? Because if we were in the idle state, we'd automatically go into the rendering state. And then we'd go into here, and then if we were in the rendering state, we'd still, so this would still, and then once we get to the bottom, we'll eventually hit the ready to render state, and at that point, we do this, and then we go back into idle. So this code here, looking at it briefly, will only execute when we're in the rendering state, which is what we want. So this should be fine where it is. I don't have to move it. And I mean, technically I could move it, but I don't think I have to. It's mostly used within this function, which is using the data. But in reality, most of this stuff doesn't, or actually, yeah, the funny thing is most of this, you know what, actually most of this stuff only now needs to happen once, because the rendering phase starts on one frame, but it ends on a different frame. So a lot of this code, unless it depends on stuff down here, I mean, I'll find out when I move it. But a lot of this stuff now doesn't have to happen here. It can happen here. Because it only needs to happen once, so that will also kind of alleviate some extra stuff. The only thing is, I think also this, yeah, this actually also needs to be here as well. That's another thing, actually. Another potential issue that it probably, yeah, it may have been a visual issue or might not have been, I don't know. But yeah, this only needs to happen initially, because we need to tell the command buffer to clear, set the matrix, set the render target, and do that, but only once when we're re-rendering. And then when we're going to the rendering state, we're just doing this chunk of stuff right here. And in fact, this whole little comment here that I wrote was literally me saying that I might do this in the future, what I just did. We could frame this loop in terms of batches instead, divide total minimap pixels by batch size, not match size. And to get quotient and remainder, and that's what these were. Make a loop which loops based on the value of the quotient, or don't if you know it is 1. Use threads, which I'm not going to do at the moment, but in theory this code is designed so that in theory I could actually take each of these batches and have them be separate tasks, which could allow me to do another level of multi-threading, potentially in those regards, but it's not a super big concern. This is, and ultimately that's, you're consuming more computer resources that way anyway, that could be used towards other parts of the game, right? So it's not we could be putting this towards other things, really. Привет. Hello, miner. I don't, just to be clear, I don't actually speak much Russian. I just like pronouncing Russian words and reading them. Russian/Ukraine words, and you know, reading them out and stuff. I mean, I can honestly, I'll kind of take a little break and well, let me. What happens when I do this? Okay, I'm not going anywhere. I just wanted to do something. This is kind of like one of my like little things that I like to do because I just like to do it. Where it's a game I play. It's actually a game I play with Mike sometimes. And in the game, the map takes place in either Ukraine or Russia or wherever. It's been highly debated and argued amongst the players and stuff like that. But so it's this game, or well, it's this map from this game, and you find that it's very useful to know that, to be able to say them, to read the words, not know what they mean, but to at least read them because there's road signs in the game, and they don't have an English version. It's just Russian or Ukraine, uh, Ukrainish, however you. So like, I mean, obviously they have like the English pronunciation, but like the signs won't, and so it's like, okay, uh, what letters do like how do you spell them and stuff like that? Uh, have a good example here that really a really Russian sounding name. I think actually, and one that I'm not going to butcher also. Oh yeah, I mean this is a good example, but I don't think it's like. So it's like Svetloyarsk, like that, or wait a minute, I know I got a better one. Oh yeah, this one's a mouthful. You have Novodmitrovsk, Novod Mitrovsk, Novomitro, Novod, no, it's Novod Mitrovsk. There we go. May I ask how you play? Oh, you're asking about the game? Not say the word for I know what word you mean probably. Well, the game's called DayZ, so it's like it's a survival game. It's not. This isn't the game. This is just the map of the game world, right? So like you use this when you're navigating in the game. It's a first person shooter. It's a survival game. Uh, most words equals curse words. Yeah, the first ones you learn. And then there's oh yeah, that one, that weird letter. The or it's I think I always pronounce this Vibor, but I believe it's Vibor from when testing like Google Translate. It would go Vibor. Or oh, this was I think the one I was looking for. This is a very Russian sounding word. Pustoshka. That's a good one to pronounce. Pustoshka. Mishkino. Bor. Pavlovo. Is that yeah. Komorovo. Balota. That was probably wrong. You gotta like pronounce each word a very specific way. But yeah, like I just a while ago I was kind of like getting into like trying to memorize uh like, oh, this letter is this equivalent letter in English because it's like that's the one thing is where certain letters that it's like the P is actually an R. Well, that one's easy to remember, but then there's ones like well, really it's the letters that I'm not really familiar with, but then you'll have like well, here's one, Staroy or Storoye. I believe it's like Staroye. Yeah. And well, the C is an S, so that's misleading. It's like usually the C makes the K sound, but I guess it's S, so it's like it's a familiar letter but a different pronunciation. Um, It's a lot of those letters. And then, of course, with this word, there's a Y sound at the end, but it's OE. So it's a lot of that kind of stuff. Oh, this one's interesting because here it's just the English, but it's actually uh three dol wait, or I don't know if that's a P or an L. It's like three dolina? Is that what that says? Dol and N, oh yeah, and the backwards N. I always have to like remember what that is. I'm pretty sure it's an I. So it's like dol or dolini, or is it dolini? I don't know. No, I'm just reading. I'm just reading words. Sol. Oh, this is one we always mispronounce because you just read it too quickly. But it's like sol nich ni, sol nich nie, or something like that. No, I'm not playing anything. No, sol nich. No, there it says sol nich. But yeah, miss any good ones. I mean, hey, uh, yeah, and there's like the ones that are hard are just like the ones where the letters are less familiar, like this W looking letter is, I guess, SH, so Shachovka or something. Um, oh yeah, that other one, yeah, because here's like Dolina, which I think probably means tree, I'm guessing. Uh, that's literally the word pioneer in Russian. Uh, Polana. Yeah, like the A, that's weird. That's another one that's weird. It's like apparently the A sound can be a backwards R, but it can also just be A. They're probably pronounced differently though. Polana. Anyway, yeah, I think we get the idea. Yeah. Oh yeah, the G is this upside down L. Gorka. Gorka. Grezino. Novaya Petrovka. But yeah, I like pronouncing. I've gotten into that. Um, but yeah, let me switch. Let me switch back. Just a little break. Just that's all it was. Just a little break from coding. That's all. That's all it was. I mean, I'm pretty sure the stream's been going for how long have we been going for? It's not really easy for me to tell unless I'm looking in the wrong place. Well, it looks like I started at 5, 5, 6. It's been almost an hour, which is good, I guess. Um, yeah, no, I was just reading words. Anyway, uh, so I think my code. Yeah, okay. Yeah, it's been a bit over an hour. So, like, this stream will just be me like refactoring just this little bit that I wanted to kind of show. This one particular thing that I was doing. Uh, there was nothing to be invited to. Nothing was happening. You're making it up in your mind. There was nothing. You didn't miss anything. Yeah, this is the the coders pool. If anything, if there's anything that you weren't invited to, it was not being invited to the coder party, which I mean that's just an obvious. That's like no duh. Like why, why would we invite you to a coder party when you're not a coder, right, Scott? Post and Bloom. Uh oh yeah, we also need the X and the Y for this as well. So okay, yeah, I was just making sure that I didn't miss anything. So Does this code total batches? I mean, in reality, this code could even be somewhere else, but it doesn't. The coder mosh pit. Had volume down, what? Had volume down, what? I said, Scott, right? Like, Mike isn't invited to the coder party. Why would he be invited to that? He's not a coder, obviously. Like, you know? Like, that's all he has to say. Mike not coder. Mike not coder. Demona coder. Demona coder. There you go. I can hear him all the way from Illinois. Fucking screaming right now. I can only imagine. Anyway, uh and you clipped stuff. Oh, okay. Sure. It means he wasn't to go coding. It means he's not a coder. Mike not coder. It's time to go coding. Yeah, the mono coder. Let's make sure. Yeah, that's fine. Rendering. Yeah, this might be uh doing all this stuff. Current grid index I, current batch plus plus. Yes, this is looking right. Yeah, I'm just trying to like preemptively see if there's any bugs, but it doesn't look like there is. Um Final batch, yeah, ready to render. And then that'll go down here and then do that and then set it to idle and do the whole thing over again. So that looks pretty much like what it should be. So I'm just going to save, we'll run it and see. There's probably going to be a bug, you know. I wouldn't be surprised. And what this should do in theory is each time this loop runs, it'll just do one batch. You know, most of the large batches are about 1,000. So this loop will go through 1,000 times. But then the third time, it's like a little bit off, right? So like the minimap is like 48 by 48. So that's about 2,304. So that's why I said 2,000 before. So it's just over 2,000 operations through this loop, pixels to determine the colors for. And so then if you divide this by the batch size, which is currently 1,020, I could make it like, I think, 1,023, like a little bit bigger, which might be good, but part of me is just like, this is fine. So if we take that number, 2,304, divide that by 1020, you get 2.25. So you get 2 full batches, and then a remaining batch, which is about 25%. And if we multiply that by 1020, then 264. So the last batch is literally just the third time, the last time in this case, this loop. Where is it? This loop will just go through like 200 some odd times. So, and then that time, the third time, it's also gonna say, let's see here. Wait a minute. Okay, yeah, I was questioning this for a minute. And then it'll say, current batch plus plus, and then it'll say final batch. Because it has a remainder, obviously. That's always going to be true in this case because we know it has a remainder. And then current batch is equal to remainder batch plus 1. So that is 3. Or, well, actually, it would be... Oh, I think I might have caught something here. Caught a potential issue. Because this should be -1. I think I might have just caught an issue there before seeing it. Because really the final batch in this case is 0 is the first, 1 is the second, 2 is the third in this case. So yeah, kind of a weird little thing going on there, but that's fine. The full batches in this case we know is 2, so it'd be 3 minus 1, so it's just, yeah. Okay, so that was probably going to be a bug that I would have had to figure out, and I just figured it out without having to run the code, run the game. And we will, if I'm confident, I will run the game. Yeah, because final batch is going to be true in this whole situation. And then this will be that. And then we'll get down here. It'll execute the command buffer and then set it back to idle. And all that good stuff. So the only thing I'm not going to change that because it's going to recompile. We'll just run and see what happens. And hopefully the map will look the way it should. It'll update at a lower rate, but that's fine because it's low resolution anyway. So let's see. There you go. How about that? Ta-da. It works. Oh, actually, let me move around and see if it's still... Yep, there we go. Minimap still works. And it updates slower. It updates at a slower rate, so it's not lagging the game as much. And it isn't multi-threading, so it's not taking up as many resources. Right, we're just spreading out the work over multiple frames. And there you go. Look, you can already kind of see what's going on, actually. It's a whole lot better now. So this is like literally like the best way to do it. So you can see, and you can kind of see what's going on a little bit here. So there's the mini map. It looks like it's kind of weird. We didn't really optimize the code. We just changed the way that it executed. So, yeah, so like I didn't take a picture obviously, but like before, I mean, if originally the code was running at like 0.38 in this kind of range, 0.38, 3887 milliseconds, right? So just keep that number in mind, about 0.39, almost 0.4 milliseconds, right? In that kind of range. And essentially what we're doing here is we're doing the same amount of work. In total, it's still taking about that much time. In fact, it might be taking, because we're using div rem, it might be taking like literally 0.3, maybe this amount of time in milliseconds. So all we're doing is we're taking that workload and dividing it amongst multiple frames, because we don't need it to run at, completely in sync with the normal frame rate. We can make it run a little bit slower. So that's what we're doing here. And if I can kind of try to, let me see if I can zoom in. You can't really, there's no manual way to zoom in, so you just have to like wait for the spike to go away and then do this weird thing. And so you can kind of see, move this down a little bit. It goes up and down, up and down, up and down. And that's because so it's like not a perfect flat line. It's kind of like a gear teeth. And that's because where it goes down, that's the frame where it's rendering that remaining bit. It's like doing that last remainder piece. And so it goes a little bit slower that time. And if I can find a good run to kind of demonstrate that and step it through it. Like, so here I'm on the frame where it's like, here it's like gen minimap. So this is the one frame where it's doing the remainder. It's about 0.07, which is really nice. But then if I step forward, you could see it's 0.17 milliseconds. And then if we step forward again, it's about 0.16, about the same time. And then when we step forward, it goes down to 0.07. So those are the 3 frames. So the Minimap right now is updating basically from what I understand here, it's updating once every 3rd frame. So if the game is running at 60 frames per second, then the Minimap is running at 20 times per second, which is more or less what you'd want in this case. And if we turn this off for the time being, and let's say like if we just play the game like this, let's see. Well, yeah, so like looking at the Minimap, it's kind of hard to see, but like I can move around and have it not like the Minimap doesn't change. So I can move around within the confines of a specific square and nothing happens. So you don't want it to like, even if I'm moving around, you don't necessarily want it to like change. You only want it to change in some certain scenarios, like, when you're moving around and you step onto a new tile, it'll update. Right. So I could have made it, and this is something I tried at some point, was making it so that the minimap only updates when the position changes of the player, like when it goes into a new tile. So like, well, actually, it'd be easier to show the debug, if I go like position. So like here, my tile position is 0, 2. Always rounding down. It's 0, 2. So then the minimap wouldn't update until this number becomes 1, right? So it means it's only updating in those kind of situations. But then you also have to consider if you're standing still, like here, and if I mine a block, like if you watch the minimap as I'm as I'm mining, it disappears apparently instantly. It appears to disappear very quickly, which is good. But what I was getting at was if you're standing like in a single tile and you're trying to update this based on events, like when the player's position changes, if I mined this block, the map would not update because I hadn't moved. It wouldn't update until you moved. So I'd have to make it so that it only updates when the player moves and also when the level changes, right? So I'd also have to hook in like, oh, level changed, and kind of do that stuff, which I considered doing, but at the same time, it actually just makes it harder to benchmark ironically, when you do it that way. Because, when I'm running this thing, it happens continuously. The minimap is continuously updating, but here it's continuously updating in pieces, right? If it was event-based, then me standing still, you wouldn't see these blue things because it wouldn't be happening. For them to show up, I'd have to be moving around and breaking stuff and whatever. So here it does make it easier to benchmark, even though technically it's doing more work in that sense. It also allows me to pull data, and we can actually see that definitively. I can grab some time here. And so on average, it appears that it now takes about 0.15. But we can kind of be a little bit more accurate and say 0.1496. So like 0.1496 milliseconds. So in contrast to, what it was previously, even though it isn't, I haven't technically optimized anything by any regards. On each frame, it is now taking up, I would say, 0.33887 divided by 0.1496. It's taking up, so it's 2.5, about 2.5 times faster. I don't know if saying it would take up 2.5 times less time. I don't know if that's the correct way of saying it. You always got to flip your words around. But it's 2.5 times faster, about maybe 2.6. So really good for just the minimap in general, because it really shouldn't take up that much time. And this doesn't even factor in the fact that there's all these other features that are going to be coming to the minimap. I'm not going to have time to do those things on stream. I might start them tonight after I finish streaming. But like we're planning on doing things like fog of war. So when you start off, you'll see like this kind of area initially. Oh, hold on, I gotta mute myself. Sorry about that. Yeah, so we'll have like a initial area that you will see, but then as you move around, like you might not see this. It might be in a black area, a dark area, a fog of war area. And then as you move around, what'll happen is we'll place like these dots, or like you'll basically uncover the areas that you've been to. And so you'll be able to see, oh yeah, this is, and it gives you a sense of like where you've been, where you've come from and where you go. Where do you come from, Cotton Eye Joe? And can be useful. It can be useful information. It's a way of just kind of laying down a trail of where you've traveled, and you can use that to find your way back. Or I'm also thinking about adding other things to make it so that navigation is a little bit easier for players as well. That kind of stuff. So, but yeah, and so fog of war kind of thing. But it also limits you in that you don't know like where things could be, right? Like you might not be able to tell that a certain cave is like here. You might not be able to see certain structures and stuff like that. But then with that limitation, we can then create new items and things like that to kind of re-grant those abilities, right? You can have certain things. So the more limitations, fair limitations that you impose on the player, that also gives more opportunities for new interesting items, which allow the player to play the game in all these different ways. Really interesting little game theory concept there, right? When you give the player too many freedoms, it makes it harder to give the player the freedom to creativity in how they want to play the game and develop strategies, right? When you're able to do anything with no limitations, there's less room for strategy, depending on how you look at it. So yeah, it's going to be doing that. And I think we're probably going to do some other things in the future. Making, like, zooming the minimap, like making it bigger, is going to be one of those things that I don't think we're going to be able to do, like, with this current refactoring, because, like you've just seen, um, like how you see the minimap changing as they're eating the wall. But you know, for those who've been listening, you know that you get the idea that this little simple thing down here can take a considerable amount of time to process. And so imagine doing that on a larger scale. Imagine making a bigger minimap showing more area potentially. It would be it would most likely be a lot slower, right? So there would be probably new strategies that we might have to employ and refactoring this again in the future to allow for that ability to be able to have a big minimap and show more. Um, I also think that we're gonna do some new things with the minimap as well. Like right now, the drill pod is like a circle on the minimap, uh, which is nice. But that also means it's kind of the drill pod is factored into this code, and that's, you know, what you see here, where the drill pod, depending on whether or not it's activated or not, will just show up kind of like that, like a circle. But it might be better to just have like a little drill pod sprite and just layer it on top of the minimap texture itself that I'm generating. And with that, we can then also add a lot more other icons. We can have other icons, things. We could potentially have icons in the minimap to kind of give players an idea of like, oh, this is a thing. And then you can mouse over those icons and maybe they have information. So when you mouse over an icon on the minimap, maybe it'll say, oh, that's the drill pod. Or if you come across a structure, maybe the icon will give you a hint of what it is. Is it an abandoned mine shaft, or is it, you know, what exactly is it? So but those objects would be things that uh, wouldn't be, they would be a part of the map, but not like pixel drawn in the same way that this stuff is. It would be its own thing, right? One other thing, I think I'm gonna end the stream here soon because I actually have dinner uh, in a bit here, but I wanted to throw some dynamite at some tatties, I guess. That's not what I wanted to do, but uh, I wanted to throw it at a wall and see what happens. I also wanted to try to find a collapsed wall or a weak wall and see what happens. Yeah, like there, you know, a boom, and it seems to update pretty quickly, which is nice. The only thing, of course, is I need to find like a weak wall, which I actually can do pretty quickly by doing this. Now you can see like just me like in this area. So like this is the loaded area for the player. Within this area, there's only 4 weak walls. So that gives you an idea of like how common they actually are, like how you know, how likely you are to kind of stumble across one of them. It's like that. So I should go across the water here if I want to find one. There's a skeleton over there too. Yeah, it's this one. And I gotta pay attention to the minimap because that's what I care about. Seeing like, oh geez. Yeah, that's pretty good. Yeah, it really doesn't need to update. Like the minimap does not need to update at like 60 frames per second. And it isn't actually. Now it's updating at like well, a third of whatever the frame rate is. So it could be like 20. So it still has the same effect. No one's gonna notice a difference. Of course, for a big mini map, if it was like gigantic, obviously that would make it a whole lot slower. But yeah, we're working with the scale that we're working with. The patties are gone. But yeah, let's see what the chat says. I minimize that. Let's see. also maybe icons in the future, other Minimap cool stuff to show off. Yeah, yeah, like icons. Yeah, like I said, the Minimap right now, it's just like it's all like, I don't know if procedurally generated is the right way of saying it, but it's like uh each pixel is manually placed, like it's like a pixel drawn thing, obviously, because it's iterating over the level and drawing that stuff. But for things like objects, it wouldn't be very CPU efficient to just have a bunch of objects and then say, oh, is this object at this, you're doing a lot of work for objects that may or may not exist and things like that. Uh, and it might be better to just have like pixel art to try to match the style of the grid style of the map that I like a lot. Uh, having how would you say, yeah, like little mini pixel art icons that would show up on the map, and they would be kind of in the same size essence of what you see here. So it might be really low res icons, which kind of indicate objects and things like that, such and such. And you could indicate a lot of things. You could indicate like creatures, maybe, or structure. We get the idea. Uh, so yeah, I think that's where I'm gonna end the stream off here. I'm gonna see how. I wonder how long the stream has been going for. I got oh yeah, 2 hours it says that we just passed 2 hours. So literally, um, what I was saying originally, once it gets past 2 hours, that might be a good time to step off. It's kind of weird. It's kind of weird that the stream started and there was 5 people watching, and then it just dipped really quickly. Um, but yeah, like Vapor, I believe was saying, it's not accurate at all. But so there could have been a lot of people watching, and I'm just not aware of it. Uh, let's see, views. Yeah, the view count's at 46, that's pretty good. So 8 likes, that's awesome. So yeah, I have dinner now. So I'm gonna. Is everything saved? Yeah. Yeah, it's been 2 hours. But yeah, if I'm pretty much done, like I think that was most of what I wanted to do. Now that the minimap work time on each frame is like about 0.1 milliseconds, which is, it used to be like worse than that. So it's overall an improvement from what it originally was. I think that confidently puts me in a position where I can start to add more features and just make those new features aren't going to slow things down, right? Because that's why I was trying to do all this optimization over the past week, so that adding new features isn't going to slow it down. So hopefully, I can move on from all of that and actually start adding new features to the minimap. But yeah, so thank you all for watching. If I'm ever up to it in the future, I'll do another stream. It's gonna be like, it's not like that frequent, just once in a while if I feel like doing one. So yeah, just keep an eye out for whenever I do the next one. But yeah, so thank you all for watching, and I will see you guys in the next stream, or I'll see you on the Discord, or I'll see you in another video that I'll post on my YouTube channel.